Yeah, so last year we had what we called our grease wall, where we invited our customers to come in and ask us questions they had about our greases. And so from that wall, we identified a couple key themes. Two of those themes we're highlighting today are one about wear protection, and the second one is about the capabilities of our greases to handle water, such as de-icing fluids or just rainwater. So what I'd like to show you here today is this is Mobile Grease 33. This is fresh material right out of our can. And what we did was take our grease and added 10% water to it, and then we placed it in an oven for 2 days at a high temperature. And then after 2 days, we looked at the grease to see what effect the water had on the grease. And what you can see of our product, that after 2 days, we found there almost no change in the color or appearance of the product after 2 days. We then took another industry-approved grease, and this is what it looks like before use. And we added the same thing, 10% water to this grease, and then we placed it in the oven for 2 days. And what we saw after 2 days, we saw a very big degree in degradation of the product. In this case, we saw a dramatic change in color, where the grease went from a dark green to a black appearance. And what we suspect is some type of reaction is occurring between the competitive grease and water when it's exposed to it in the field. Yeah, with our second demonstration here today, we're demonstrating to our customers the extra wear protection they get with using ExxonMobil greases for aviation applications. And in this case, we ran one industry test. It's commonly called the 4-ball weld test. And what this test does is measure the load carrying capabilities of your grease and when it's used in a bearing. A common application for bearing would be something like a landing gear. And so what we demonstrated with our product is that we can actually handle higher loads than the competition can with their product. We looked at 2 different types of greases used in the aviation industry. One is a BMS 3-33 type grease, and the other type is a general purpose aviation type grease that's used throughout the aircraft. And in the first example with the BMS 33 aviation grease, what we found is that it can handle much higher loads. And so the test is basically, if we take this example, is 3 balls and then a 4th ball placed on top of that and immersed in grease. And then what we do is start applying load to the top of it while we're spinning the top ball. And the test is considered a failure when you get to a load that causes the balls to actually weld together with each other. And so we ran this test up to 500 kilograms, which is a fairly high load for this test. And what you can see with the ExxonMobil product is that all 3 ball bearings are free from each other. They're not welded together. When we looked at 2 competitive products, the first one, we saw, in this case, all 3 balls welded together, as well as you can also see high levels of wear occurring at the same time. And then in the second product, competitive product, in this case, we saw all 4 balls were actually welded together with each other. And you can actually see some of what welders would probably call like slag or pieces of metal hanging off the side. So late last year, we just increased the shelf life on our products. We have an industry-leading shelf life. Our products are good from anywhere from 2 to 3 times longer than our competition. And this, in combination with good storage and handling practices, allows our customers to have an extra degree of protection while at the same time ensuring quality of the product over time.